Hello everybody and welcome to this webinar on FiberPlanIT. My name is Jonas Verstuyft and I'll be presenting today. Let's start off with the agenda for this webinar. So I'll start with a short introduction, then we'll immediately move on to the product demonstrations of the FiberPlanIT products, the simulator, designer, and engineer. We'll finish this webinar with a short wrap-up conclusion and a Q&A session. I expect this webinar to take around 45 minutes. You can ask your questions via the GoToWebinar Q&A window, which should be located on the right-hand side of your screen. And I'll treat the questions at the end. So feel free to ask your questions throughout the webinar. I'll run through them at the end of the session. Then after the webinar, you will be redirected to a website where there will be a short survey. If you could answer, I think it's around 7-8 questions. This should only take 3-4 minutes. That will be very helpful. And then later this week, you can expect an email with the recording. So if you want to share the recording afterwards or watch it again, you'll have the chance to. All right, so let's get started. I first want to introduce a bit the company. So I'm from a company Comsof, and we are located in Ghent in Belgium, at least I am. We also have an office in Toronto in Canada. The company got founded in 1998, and we have been developing the solution FiberPlanIT and doing projects with it since 2011 already. All right, so let me start off with, I think maybe kicking in an open door. In the market today, what we see is that there's a need for higher bandwidth because of and lower latency because of new applications that are coming up, 4K video, 8K video, virtual reality applications, but also new technologies which require fiber connectivity and higher bandwidth, like 5G and small cells, G.fast or DOCSIS 3.1. So for these technologies, you need to bring fiber closer to the home to be able to guarantee and leverage the existing infrastructure and provide higher bandwidth. Now, for this, like I said, new fiber networks will need to be deployed. Extra fiber need to be put into the ground or on the poles to be able to provide that higher bandwidth. So new networks are being created, greenfield deployments in new territories or new players entering the market. We also see network expansions happening everywhere. So existing networks which are being expanded to new neighborhoods as well, new builds, and also network upgrades. Like I said, G.fast, DOCSIS 3.1, this reuses the existing infrastructure, and you want to upgrade your network to be able to benefit from these new technologies. Now, what we see in the market is that every rollout is somewhat unique. It all has its particular aspects to it, and that's not only in the high level sense. So fiber to the home versus fiber to the business, where they require extra reliability, extra redundancy, maybe ring topologies. Also fiber to the antenna or fiber to the cabinet, which needs its own capacities and network speeds, or even mixed designs where you service a different number of endpoint locations with fiber. But also within these FTTX flavors, you see a lot of different architectures. Within fiber to the home, you have PON deployments or point-to-point deployments. So there's a lot of different things to consider, and each project will be different in some way, either because of the architecture guidelines and the FTTX flavors, but also because they're being applied taking into account local conditions or because of using particular equipment. Now, let's take a look at the process of an FTTX project, going from an idea of building a new network to the actual construction. So what we see three big steps in that process. First one is the planning, so creating a business case for your network rollout. Second step being the design. So once you've made a decision, you need that outside plan design of your target area. And third being the actual rollout and connection of all your customers, so you can start bringing in the revenue, of course. Now, with this project, we see three different challenges as well. So throughout the process, you need to keep your costs under control. Deploying a fiber network, whether it's underground or overhead, it will always be quite expensive. So throughout the project, you need to be able to manage those costs within the different steps. Second, you need to ensure high quality for the design, but also for the design, meaning for the actual construction, but also later when operating a network. You want to build a network which can last for many, many years. So you need to avoid introducing errors, missing homes, and keep your designs consistent of high quality, so that later on when you try to connect a customer, everything is clear for the user to how to do that. Third challenge is time. There will be time pressure, either internally from management, from marketing, wanting to connect customers with and trying to offer higher bandwidth as soon as possible, or externally from competition coming into the area, trying to lure your customers away if they're able to offer higher speeds and a better service. So these challenges need to be managed throughout the process. All right, so let's go into a bit of detail in the three different steps that I mentioned. So the first step is to decide on your rollout plan. What does that mean? That means whether you're looking at a large area, national coverage, then you would need to decide which cities do you want to roll out your network, or even which neighborhoods do you want to roll out your network, and that applies to small and large operators. Then you also want to plan for years to come. So you want to make a plan for the next coming years. What fits within my budget? Where can I roll out my network when? And then what technology do you want to use? Like I said in the introduction, you have G.fast coming up, DOCSIS 3.1, which can provide an alternative for fiber to the home. So you would also want to make that decision early in your project. And the basis, what we see for making these decisions, is having access to accurate cost information. So you need data that you can trust, so that you can build your business case for each scenario that you have in mind. Then what we see is that most companies, they turn to spreadsheet modeling when it comes to getting that cost information. But yeah, that can be quite, what we see is it can be quite inaccurate or very complex if you want to create formulas taking into account the density, number of homes, all the equipment costs. Trying to capture that, all of that in a spreadsheet can be quite complex and can be easy to make mistakes in that step. Now, what we want to do is provide an alternative for that, which is the FiberPlanIT simulator. So what I'll do is I'll go into a demo of the simulator to show how it can get that accurate cost information that you need. All right. So this is the simulator, and what is the simulator? The simulator is an FITX planning tool that can provide that accurate cost information. So what it does, it calculates the costs of your network deployment, so deployment cost, activation cost, or cost per home passed, based on the actual design of your network. So what you see is an example of what the design would look like. Now, how does the software do this? Well, to be able to design a network for your area, you can load in the GIS information for that area. So for greenfield deployments, this would mean basic input data like your demand points, meaning the endpoint locations that require fiber connection, and your street center lines, so information on the streets, so that the software can determine where to route cables. You can also load more advanced information, which can be used for brownfield or aerial deployment, like existing infrastructure, existing conduits, pipes, or poles for aerial deployment. And then also, if you're looking at G.fast, you can load in existing copper information, which can be used in the calculation. Now, what I said is the software calculates your network. So based on your area, it will apply your design guidelines. So the software allows you to configure the network architecture that you want to apply to your area. And in the design rules, like we call that, you can specify what your network looks like. So for example, indicate whether you want a PON or a point-to-point type network in case of a fiber to the home deployment, where you want to place your splitters. So in this case, we have a centralized splitting configuration with a 1/32 splitter, but also more advanced settings like the capacity of a distribution point can be configured in the rules. Next to that, of course, we need we want to calculate the cost information of the network deployment of the design. So you would also need to provide unit cost information of the equipment. So for example, we see the cost of the splitters here and of the trenching. Then these rules will be applied to your area, and that will result in a design, where we see the example here, and also a bill of material. And a bill of material that is provided by the software goes in quite some detail. So it gives you high-level information of your network design, like the total cost of the project, deployment cost per home passed, and then also breakdown per layer in your network, so depending on the network architecture. And then a detailed breakdown of all the equipment that is needed to build a design. So, like I said, this bill of material is based on an actual design calculation. So what you see here, for example, for your distribution, the amount of cabinets that we need, 24 cabinets. This is based on your architecture and the particular area that we are working on. You can see the unit cost information that's specified in the design rules, and then the total cost that is needed for these cabinets. Same applies to cables, to ducts, to splicing, splitters, and so on. What we also have available is a insight into the expected revenue. So in the input data, you can specify the expected adoption rate for your endpoints. and the average revenue per user that you expect. Then the software, you can set the project timeline, and the software can calculate what the expected monthly revenue and total revenue will be for that design. So that helps you to build your business case, of course. Now, the calculation of such an area is highly automated. As we can see here, for this area of 2,000, almost 2,600 homes, this calculation takes less than 4 minutes. So this allows us to get accurate cost information in a fast way. And this would then allow us to batch certain calculations to get insight in particular scenarios. For example, if we're looking at a larger city, then we can run calculations on all the areas that we have in mind in one go and apply the rules to that area to get that cost information. The same could be done for all of the different network architectures that we have in mind. Just run them on all the areas that we have in mind to help us make the decision on the type of deployment that we want. And then a more advanced feature that we also support is doing area coverage calculations. So, for example, you can run calculations for 90, 70, 50% of coverage for your area. So imagine a larger area that you're looking at. There will always be some remote locations which are more expensive to reach. So instead of looking at a full 100% deployment for every area that you're evaluating, it might be interesting to lower the coverage per area and then cover more areas for the same budget and make your project a success. All right, so that concludes the demo on the FiberPlanIT simulator. Now, if we go back to the different steps, so we've the first step is to come up with a business case, make the plan on where you want to roll out your network and what type of network you want to roll out. Then the second step is, once you've made a decision and you want to go out and deploy your network, the first thing you need is a design of the network. So you need to know what equipment needs to go where within my neighborhood level or central office area. So where do you place your cabinets? Where do you place your cables, your ducts? Where do you need to do trenching? But also, what type of cables and ducts, what type of equipment do you need? What's the size of all the equipment that I will need in my area? So you need valid designs based on the design guidelines you have set out, the network architecture that is specified, but also cost-effective designs. Like I said, deploying a fiber network is expensive, trenching is expensive, so you want your routing to be as efficient as possible to keep those costs under control. Now, you can go to a manual way of working using CAD systems, using a GIS system, or drawing in Google Earth. You can draw your network design, your high-level design, but what we see is that it's easy to introduce errors in this process. So sometimes the rules, the design guidelines are not followed to the letter. There's an interpretation of the guidelines depending on the local situation. It can happen that some homes are being missed, or that not enough capacity is foreseen in cables or ducts. And secondly, it's a slow process. It's labor intensive to design a network, definitely a larger area. That's why we want to use the FiberPlanIT designer within that design stage. So I will now go into a demo of the FiberPlanIT designer. All right. So for the designer, a similar process is being used as for the simulator. So what's also happening is we also need the GIS data of your area. So if we take a look here, we have similar GIS data as before. We have our demand points, our buildings that require connection. We have our street layout, but we also have some pole infrastructure and existing infrastructure like you see here, some existing manholes and some existing conduits. Basic GIS data, and what the designer also does is apply the rules that you configure to the area. And then what you get as a result of a design calculation with the designer is a detailed view on the equipment that you need and where you need it. So if we took a look at one example here, so the software calculates the whole design from every single demand point, every endpoint location, back to our central office location. So we see for every step of the way which type of equipment that we need. If we look here, we have our lead-in into the building. We see that we need a 2-fiber cable. Type is underground cable. So that is determined by the software and by the rules that have been configured in the software. The same we can see for the duct. So here we need a two-way microduct bundle. Then we can trace this back to the distribution point. So we have a 2-fiber cable running in this trench here to the distribution point. And then we have the feeder cable. So this is a feeder cable that runs past feeding different distribution points, each time splicing off some fibers. And then this is traced back to the central office. So this is a 96-fiber cable. And if we take a look here in our distribution point, we can see that we need a splitter, which is a 32-way splitter, which is based on the design rules that we configure. Now, to go back into some detail on those design rules, in the design stage, it's really important that you are able to follow the design guidelines, the network architecture that you have in mind. So you need to make sure that you can configure everything in the solution here. And what I want to show is that the setup of the system is quite flexible, and this is also based on projects done in many different parts of the world. We've seen a lot of different types of deployment methods. And one thing that I want to take a look at is some more advanced configurations which might be in your guidelines, but that would be hard to manage if you're doing a manual design. For example, if we look at the ducts here for distribution, we can see that we can use two types of distribution ducts, 12-way duct, 24-way duct. Now, we have configured spare capacity for these ducts. So the software will take this spare capacity into account when doing the design, but when doing this manual, it might be easily overlooked. So putting in spare capacity for ducts, reserving fibers for cables, this is something that's quite easily overlooked and needs to be taken care of. Now, secondly, the software requires you to specify the cost of material and labor. This is not only used for determining the bill of material, like I showed in the simulator demo. So that bill of material is also available in the designer. It's not only used for determining the bill of material, but these costs are also used in our algorithms for routing and for doing doing the design. So it tries to optimize the costs for your routing, for your equipment placement. So rerouting based on cost, or cost of trenching, or maybe being able to reuse existing infrastructure. So this is something that we can see here. So we allow the user to specify a cost for trenching, a cost for reusing existing pipes. So preference, as we can see here, a cost of 40 euros versus 0.1. See, the software will prefer reusing the existing conduits as much as possible to lower the cost. And what we also allow the user to do is specify different subtypes for the trenching. So there might be different trenching methodologies, and depending on the surface of the ground, there might be more or less expensive ways of trenching. So we allow the user to specify this in the input data, assign a cost to it, and then reuse that for the design, so that you get cost-effective designs taking into account the local conditions. And so after defining the rules and loading in the GIS data, you get to your design. Of course, you want a design which is valid, so according to the architecture, but also a design which is constructible, which is feasible within your area. And we try to give our users as much control as possible over that design, while still keeping it valid and according to the guidelines. And there's two ways that the designer can help you to have control over the design. One is you can influence the routing options which are available in the software. So you can see here the way that it's routed the software right next to the street. So this can be influenced. And secondly, it's giving the user the power to fine-tune the design after calculation. So first off, I'll take a look at how you can influence routing options. Now, based on the GIS input data, the software has an automatic way of processing this data and calculating possible routes for the software to use. If we look at the underground data, this means that you will get underground lead-ins, see the lead-ins here, trenches, and possible crossing locations. Now, the user has the possibility to edit this information and to exclude where needed. So this is included trench, exclude certain routes which you know that are not able to be used. What you can also do is specify a subtype for streets for possible trenching, which, like we saw in the rules, can be used to optimize the routing and make it more cost effective. Another way that you can influence the routing is, for example, you can edit all of this information, and what you can do is edit the lead-in, the way that the cable needs to enter the building, which can have an impact on the bill of materials. So to make sure that this is exactly correct, you can change the way that the lead-in is being done, and this will be reflected in the design and in the cable length. Now, the second way that you can influence the design is, like I said, influence the output of the design. and what can you change in that output. So what you're possible to change is that you can see these polygons drawn around our distribution point locations. Now you can edit these clusters. The size of the cluster is defined by the design rules, but as a user you have the power to override this decision. So you can go in and edit these clusters, these polygons. So by editing these polygons, by including these buildings in this polygon, we tell the software to service these homes from this distribution point. So here we see the cable running there, and I'll take a look in a minute to the alternative. So the result of this change. First, I want to show another impact that you can have as a user is you can change the locations of these distribution points. So what does that mean? For example, the software decided to place a distribution point here. So in the field, you would need to place a cabinet there. Now, if you know that that location is not feasible, you would want to edit that location. So as a user, you can change that location to a different location. Now, let's take a look at the outcome of such a change. If we load change to calculation here. Now, what we see is the distribution cables being routed now from this updated location to our homes. So these kind of changes are quite easy to make with the software. Just changing polygons, changing the location, rerunning a calculation, and you get an updated design and an updated bill of material. While if you want to do this manually, this would be a work of maybe a full day or a couple of hours. Now, what I also want to show is the flexibility of the design rules. For this, I want to take a look at a different workspace. So it's the same area, but a different set of rules which are configured. And the set of rules that are configured here is automatic ring calculation. So we have the capability in the software to automatically calculate ring topology. So you can see here the purple ring serving different distribution point locations. And then we have a yellow ring with branch cables serving these set of distribution points. And as a user, you have the capability to go in and edit these cables as well. All right, so we've arrived at the final stage of our process, which is to build and construct the network. Now, for this stage, what is important is that you exactly know what equipment you will need and where to exactly place it. Also, you need to know how to connect everything together. So how do you need to splice all fibers together, how to splice on the splitters, how to place cables in microducts. And for this, you need clear and consistent construction plans so that the field team exactly knows what to do and knows how to build the design that you made. Now, for this, you can go to, again, a manual design process using CAD tools to draw the network. You can use Excel for creating your splice overview. You can use Visio or also CAD for drawing diagrams that can help the field teams. But again, what we see here is quite error prone. It's easy to make a mistake, to use the wrong label, for example, which screws up the network. And the design itself is quite slow, quite labor intensive, very repetitive, can be very repetitive work. Now, for this, I want to show you the FiberPlanIT engineer to show you how this solution can help you at this stage of your project. Now, right. So the FiberPlanIT engineer is a solution based on AutoCAD Map 3D. And the input data that's required for the engineer is the high-level design, which is done with the FiberPlanIT designer. The design can either be done in a QGIS environment, like we saw earlier in the demo, but the designer is also available as a plugin for AutoCAD. So you have the same functionality available in AutoCAD Map 3D. Now, if we have our design which is done with the designer, we can convert this design to a low-level design in Engineer. And for this, like with the designer, you have a set of rules that you want to apply to your low-level design. So when configuring a high-level to low-level design with our solution, what it will do is it will add all of the labels to the equipment. It will do the splicing automatically, add the coloring for cables for microducts, all in an automatic way. You as a user have the capability to specify the way that you want to do all of this. So, for example, one of the things that you need to specify is the naming configuration. So for all the equipment that is generated with the designer, you can specify the template for the label that you want to give to that equipment. This can be done by a set of placeholders, and this makes sure that there's no mistake in the labels. Make sure that labels are not being used make sure that all labels are unique as well. So this can be done for cables, ducts, your clusters, points, trenches, and so on. Secondly, also the splicing is done automatically, and there's a set of configuration settings so that you can make sure that your low-level design reflects the way that you want it to be. Now, if we take a look at that low-level design that will come out of this transformation, you can see that this looks quite similar to our high-level design, with the main difference in the map view here is that we now have our labels being assigned. So our distribution point 1.5, we have our ducts with the correct labels as well. So all of that information has been added. And now what we need from our low-level design, what we're looking for is those construction plans that we want to give to the teams in the field so that they can go and construct the network. And for this, we have a documentation pack client, which allows you to specify all the type of plans, reports, plots that you need for each and every single design. So here we have three sort of output documents that will be generated for this design. And if we take a look at the example output, and you can see we have our construction plan that's generated, which is a PDF format, similar as what you see in the AutoCAD environment, with all the correct labels so that the team knows where to place which ducts. We also get our permit plans. So which indicates where you will do your trenching, where you will place all the equipment. And most importantly, all of the splicing reports are also being generated in a consistent and automatic way. So here we see for the same distribution point closure we were looking at, we see the incoming cables, incoming fibers with the right color, and the outgoing fibers, so that the team knows exactly which fiber to connect to which incoming fiber to connect to which outgoing fiber. So all of these reports can be generated in an automatic way. Now, the low-level design is you're also able to go into detail in the different elements that are available. You're also allowed to make changes to the design itself, and it allows you to inspect your low-level design in a more graphical way. So if we look at that same closure that we were looking at before, if we look at the splice diagram, we see our incoming cables, so our fiber bundles, 4 fiber bundles, our splicing trays, and our outgoing cables. And then we have a set of splitters as well in this closure. So this assignment is something that's been done automatically and can be also changed by the user. Now, our low-level design is a fully connected, on the fiber level, fully connected network. And what we can do is we can have a look at the path that is being followed for one particular endpoint, one demand point. We can generate the connectivity overview going back from our endpoint, this demand point. We can follow the full path that is being used. So every cable section that is being used and every point that is being passed. So we go to our drop point location, following cable to our distribution point through a splitter, and then we have our feeder cable entering the central office. So all of the details that you expect from a low-level design ready for construction. All right, so this was a short introduction to our different solutions that we have available. To conclude this webinar, I want to go through them one by one. So we went to we had a look at the FiberPlanIT simulator. So mainly used in strategic planning stages, helping you to reduce the risk of your project. The way that we can do that, as I've shown, it uses the GIS data and the accuracy of that GIS data, and it gives you a detailed view on the costs, very detailed breakdown per equipment type, as we saw in the bill of material. Because it's an automated solution, it allows you to compare in detail different architectures, different regions that you have in mind, and get that cost information. Then we had a look at the FiberPlanIT Designer. So the Designer, it's a highly automated solution, uses optimization algorithms to reduce the cost of your network. Make sure that you use efficient routing of cables and ducts. And it allows you to have uniform, high-quality designs following the design guidelines that you set forth. Lastly, we had a look at the FiberPlanIT Engineer. What I wanted to show is that it can help you to speed up your network deployment. You can automate your low-level design stage, create those labels, naming, splicing, coloring, all in an automatic way, and get those construction plans and all reports out automatically. Now, like I said in the introduction, we've been around for since 1998 with FiberPlanIT since 2011. Since 2011, we've been doing projects all around the world. We've been in 45 countries, done over more than 200 projects. So it's a proven solution, and we've built in the right amount of flexibility to be able to support all the different rule sets around that we see around the world. Lastly, I want to go into our have a look at maybe later stages for your project. So we covered planning until building of your network. Of course, you want to go and connect your customers, get them on a subscription. So you will need to operate your network and have a good view on what your network looks like and how to connect all the customers. For this, you will need a physical network inventory solution, and through our partners, we integrate with these solutions so that the process can be you can have a seamless process from design building up until the operational stage and not lose any information in between. Also, during the planning, design, and build stage, we work together with a number of partners that offer tools that can help you along the way. For example, mobile survey tool that can help the people in the field to visualize the design, the GIS data, make changes right into the field. Also, mobile mapping. You can use mobile mapping data within these different stages. So LiDAR information, which might be captured for your area. You can use that information. This can help you to make sure that you get valid designs which are constructible. All right, so today we handled our 3 different products: simulator, designer, engineer. Of course, we can also offer services mainly focused on strategic planning services, design and construction services. You can offer through partners. So feel free to reach out to us via email or by going to the website. And now we still have a couple of minutes to answer a few questions. So if you still have some questions, please feel free to ask them in the question window, which is on the right hand side, and I'll be happy to answer them. Let me just have a look here. One of the questions that I see is, what is the price for the different solutions? So it's a question we often get. Well, we have the 3 different solutions, and we have projects ranging from smaller projects, city level, or smaller, and national operators. So our pricing models are quite flexible to cover, to make your business case and make it worthwhile to use our tools in the different for the different sizes of your project. Another question is, what are the system requirements for the solution? So our solutions are all desktop based solutions, so running on Windows PC. If you have a recent desktop or laptop, you will sure be able to run our tools. All right, so that is it for today. I want to wrap up the session by announcing a couple of events where we will be present at. So next month we will be at ISE Expo in Orlando, Florida. Going beginning of October, FTTH Africa, and then end of October to Broadband World Forum in Germany. So if you're attending one of these events, please feel free to pass by and have a talk. All right, so thank you very much for attending this webinar and have a great day.